Two. I'm only going to go over two of these with you. You got the rest on your own and for the weekend. We have the density of an American white oak tree. How about that? 752 cubic meters. The trunk has a circumference of 4.5 meters and a height. Yep. What's the approximate number of kilograms in the trunk? All right, two things before we start. Can we first agree on what shape the trunk of a tree has? Cylinder. All right, all you sphere people get out. Okay, it's a cylinder. All right, so we have a cylinder. Quick check. Second thing, quick check. Or how about our units here? Where are we here as far as the units go? Do we need to convert or are we okay? 4.5 meters for the circumference, and the density is per cubic meter, so we're good to go. So we do have the volume of a cylinder first. Pi r squared times the height. Oh boy, I have the height. I do not have the radius. What else is given to us about the trunk? Circumference. Anybody know the circumference formula we like to use around here? Little pi d. I can certainly get the radius from that. So I have 4.5 equal to pi d. We can solve for the diameter. I'm getting 1.4323 94488. Again, not rounding anything. There's your diameter. I'm not going to write it out, but you can cut it in half right now before you go back to the volume formula. Pi, and then when you cut it in half, we got a little 0.71619. 72439 squared, and they gave us the height of 8. And what do you have here? 12.8 9155. So there's the volume of one of the trunks. So let's go to density now because you're looking for the mass. Mass divided by volume. Density 752. Looking for the mass of one over the volume we just found. When you get to that point, I'll ask somebody here. It does say approximate, so I'm just going to say nearest kilogram for me, please. Nearest kilogram. Bless you. First person up for the day. 7 when you're ready. 7. 7. Way to keep her in check. Anything else here before we go? One hardcore problem together, and then you're on your own. All right, let's fill up some pools. I'm not going to, I decided against that. I'm going to go 7. Here we go. Teresa versus Nancy. Who pays more to fill up their pool? And that is a lot of reading, huh? Oh boy, if you need assistance, ask somebody next to you. Woo! Here we go. Look at Teresa. She's got a rectangular pool. She fills it using the city water. They charge her $3.95 for every 100 gallons. And then Nancy's like, hey, I got a circular pool with a diameter of 24 and a depth of 4. She's not a big fan of the city water, so she's got her own service. Wow, 200 for every 6,000 gallons. Here's the catch, though. Both of them only fill it 6 inches from the top. 6 inches from the top, not all the way. Who paid more? And I know this isn't the most professional here, but this should be saying 1 cubic foot equals 7.48 gallons. Okay. All right, so volume, why volume? Well, we're filling up a pool, and number 2, it's in cubic feet. So let's go Teresa first. Let's compute how much she's going to have to pay. And I know some of you just want to get going 30 times 15 times 4. That's not how we're rolling on this one. Not how we're rolling. Why not? I'll go 30 times 15, but I'm not putting the 4 in there. She doesn't fill it all the way to the top. She fills it 6 inches. Inches from the top. What's this all in? Feet. So this 6 inches, half a foot from the top. So what do we want to do here? Not multiply it by 4, but 3.5. Everyone all right where that's coming from? Bless you. So the volume of water in her pool, 1,575 cubic feet. All right, next up, what do we have to turn that cubic feet into? She gets charged for the gallons, yes, so we need to convert it into gallons. So next step here. And again, if you're still confused, multiply, divide, I don't know, write a darn ratio. 1 cubic foot is 7.48 gallons. How many gallons for 1,575 cubic feet? And then we have 11,781 gallons. All right, not too bad. But she doesn't get charged by the gallon. She gets charged by the 100 gallons of water. A little bit different now. Still can be solved by setting up another proportion. So from the problem, it says every 100 gallons, you're going to charge me $3.95. Make sure the units go across from each other. So I'm going to put my 11,781 across from the 100. How much are you going to charge me? And we are talking money, so you don't need to write out a full decimal, but probably to the nearest cent. $465.35. Teresa will be charged. You think you can handle Nancy on your own? Only difference is, well, 2 differences. 1, her pool's a different shape. And 2, she's getting charged a different amount. So go ahead, find out how much Nancy will be charged. Okay, and this discussion is going to happen It says a circular pool. There's no such thing as a spherical pool. Okay, that would be in the shape of a cylinder, everybody. Is there a spherical pool? It's called drowning. Yes. Good luck getting out of there.
I know that one.
Let's take a big ball and fill it with water. Good luck. Yep. As you're as you're finishing up, take a look. Nancy's paying $394.79, a little bit less than Teresa, so we're going to say Teresa pays more. All right. I'm going to let you go on your own. If you want to get out your laptops and look at the answers on Aspen for these problems, go right ahead. I will let you know, last thing, all these problems are all old Regents problems, including this one we just did, have shown up on old Regents. When you get to number 8, number 6 with Big Al and taking a kickboxing class, that was last year's Regents question in June. It wasn't Big Al, it was somebody else, but we just changed it. But this was the problem last year on last year's June. Every year they see him in the part 3 section of the Regents to put one of these density problems in, where you're going to have to change units. So go ahead, it's on you guys. You got plenty of time to work. I'd recommend checking your answers as you're going along.